Alright, our next video is one where we are going to combine a few ideas into one topic, and this topic is called momentum. So what exactly is momentum? Well, I've got a little definition written here. We call it a measure of the degree to which an object will tend to keep moving. You might say it's mass in motion. That's another way to think of momentum. It's basically any object that is moving has momentum. So the key things to keep in mind with regard to that are the mass of the object and its velocity. So those are the two things that are going to affect the momentum. Alright, so increase either of those and you will increase the momentum. So if we look at this picture here of the dump truck, well, that thing is got a lot of mass, right? A lot of mass. That thing's got a lot of mass. So that, if it's moving at all, is going to have kind of a lot of momentum. If it's even moving very slowly, it will have a significant amount of momentum, and you will not want to get hit by it, even if it's only going maybe 1 or 2 kilometers per hour. Even still, you don't want to get hit. So let's compare that then to this guy. He has a plastic wiffle ball bat, and this is a plastic wiffle ball. I don't know if you guys know about wiffle balls, but they're the little plastic balls with holes in them. Let's compare this to this. Say this guy's swinging even 60 times faster than this thing is moving. Do you think he's anywhere near the same momentum? The answer is no, because he has so much less mass. Okay? So the key idea with momentum is mass and velocity both. Okay, so that brings us to our way that we calculate momentum. And the way we calculate momentum is using this equation. So momentum is equal to mass of the object times its velocity. Alright, so mass times velocity is your formula for momentum. How much stuff there is and how fast it's moving. Those two key factors are how you figure out how much momentum the thing has. And then if we use the traditional symbols for momentum, traditional symbols, those would be little p, mass, and m and v. So this is the symbol for momentum. Alright, I'll just right there. And then mass and velocity. Alright, so that's your equation, that guy right there. So as long as you know mass and velocity, you can calculate momentum. Alternatively, if you happen to know the momentum, you could calculate either of these two quantities, assuming you knew one of them. Okay. Alright, so this brings us to another important point about momentum. You will notice it has this term, velocity. And if you recall from previous videos, velocity is a vector. Vector, not a scalar. So there's a vector in this equation. That means that momentum is a vector. So momentum is a vector. Alright, that means it's not enough to just give its numerical value. It's not a scalar, it's a vector. So you have not totally given the answer of what the momentum is unless you give a direction as well. So let's just say the momentum of an object, let's say 1 kilogram, at 10 meters per second. What's the momentum of that thing? Well, mass times velocity. The momentum would be 1 times 10. So the momentum equals 10. And the units are standard units are kilogram times meters divided by seconds. Alright, but which direction? Well, let's clarify. Our velocity is plus 10 meters per second. So we'll say that the momentum is plus 10 kilogram meters per second. All right, remember if we're talking about a straight line motion, then we can define one direction as negative and one direction as positive. And that means that all you need to do in order to indicate the direction is say whether it's a minus direction or the plus direction. So since we've said plus, we've given a direction. We are now complete. This is our answer. Okay? Now the last thing I want to cover in this video is the idea of the conservation of momentum. Okay? So this is the basic idea of conservation of momentum. If you have a closed system, say this group of balls right here that are hanging from strings in order to minimize friction and minimize energy loss. I'm sure most of you guys have seen something like this. You pull the ball back at the end, you let it go, it swings down, it hits these balls. What happens? Well, this one over here pops off because momentum is conserved in the system. The amount of momentum that this ball has is communicated through all of these three balls and into this one, and this one swings out. If no energy is lost, then this one will swing out the exact same amount that this one started at, and then it's going to swing back, and the exact same thing happens in reverse. This one pops out, swings back, bam, this one pops out, swings back. What never ever happens is if this guy swings in, and then, oh, we gained some momentum, both of these guys swing out. That will never happen, all right? However, if I pull two of these guys back, double the mass, double the momentum, and swing them, then I get two of them that come out the other side. All right. So however many balls I swing in is the number of balls that swing out, and however far I pulled them back is how far these come out in the end. Now, of course, eventually this stops working because energy is lost due to friction over time, but it'll run for a while. So that's the idea of conservation of momentum. Whatever momentum you start with in a closed system is the same momentum you will keep throughout the whole process, all right? And it turns out that that's really important for solving some problems and doing some work with the idea of momentum. But that's enough for this video. So those are the basic ideas of momentum, and that's how you calculate it, and we'll look forward to talking more about it in the next video. Thanks for watching.